Before we continue with this episode, please ensure that you are familiar with the following: binary conversion, IP addresses, subnet prefixes, IP classes, the difference between unicast, multicast, and broadcast. Subnetting is the act of separating a network. Subnets are important because they allow us to divide networks, broadcast domains, and simply allow for a more organized network. Broadcasts are used for things such as Address Resolution Protocol, or ARP, which is a protocol that sends a layer 2 broadcasts. Keep in mind that routers do not forward broadcasts beyond their subnet. Not subnetting your network will result in a larger broadcast domain, which will reduce network performance and take resources away from host devices. Take a look at this chart. Normally, these three networks are one whole network themselves. They stay within their octet boundary. Notice how the chart changes when we borrow bits from the host portion. By taking away one host bit from the subnet mask, we split our network in half. If you want to know how the subnets will go in increments, we can look at the magic number. The magic number is the value of the last bit in your subnet mask. If we look at what we borrowed 128. Our subnet mask has changed to 255, 255, 255, 128. This means that our network went from one network with 256 addresses to two networks with 128 addresses each. Notice this bit. If we look at our positional notation chart, we observe that the value of the last bit is 28, hence the magic number. If we take another bit and change our subnet mask to 255.255.255.192, we now have 4 subnets. Every time you borrow a bit, you double the amount of subnets you have while decreasing the amount of hosts per subnet. If we look at the magic number now, we can notice that the last bit is 64, meaning we have 4 networks with 64 addresses per network. The magic number applies to the other network classes if we apply the octet boundaries. As an example, the subnet mask 255.255.0.0 has the last value on the place 65,536. As a result, this network has 65,536 addresses available for this subnet. However, it has not been subnetted. When we borrow one bit, it will split the network in half, giving us 2 networks with 32,768 addresses each. Just keep in mind that by borrowing bits, we continue splitting up our subnets. When subnetting, you need to keep in mind these 2 formulas. The first formula will allow you to see how many subnets you are creating. It goes 2 to the power of n. N being how many host bits you borrow and turn into network bits for your subnet mask. As an example, if I borrow 4 host bits and turn them into network bits, I get 16 when I do 2 to the power of 4, giving me, again, 16 subnets. The other equation is the host address equation. This equation is 2 to the power of h minus 2. With the amount of host bits you have remaining, plug them into h. As an example, if I have 4 host bits left with my subnet mask 255.255.255.240, 2 to the power of 4 minus 2 will give me 14. Now hold on, why am I subtracting 2? Well, remember that the network address and the broadcast address are not assignable, so we'll subtract them already to figure out how many assignable host addresses we get. Let's talk about requirements and subnetting. If we need to subnet a Class C address to have a network of 120 hosts and 2 networks of 60 hosts, would this be impossible? Well, if we use our current methods, it would be. However, I'm going to teach you a different method. This method is called Variable Length Subnet Masking, or VLSM. VLSM is basically subnetting your subnets. Let's say we subnetted once, meaning we have 2 networks with 128 addresses available for both networks. Now, if we wanted 3 networks, this would be impossible. However, we are able to split subnets. Take the second network. This network can be split again. It's just When representing it, it will use a different subnet mask. Take a look at this example. Here, we're representing all of our networks. This is our first subnet. The full address range is 192.168.0.0 to 192.168.0.127. Now, we have our other ranges. Here, we will change the subnet mask from 255.255.255.128 to 255.255.255.192. If we plug it into our host equation, we can notice that we have 62 hosts available to this subnet. From here, it's pretty simple. 192.168.0.0 will use the prefix /25, making the subnet mask 255.255.255.128. This will limit the subnet from .0 to .127. Meanwhile, we have our second subnet already split up into two more subnets. Their full address ranges are to .191 and .192 to .255. So it works out. The computer will recognize it, but what if we have new requirements? What if we need 4 networks now? One of them for 120 hosts, one for 60, and 2 of them for 28 hosts. Because you're limited in options in Control Panel, we'll only do this through Microsoft Management Console. In the User section in Local Users and Groups, you'll want to right-click the user, go to their properties, and then check what groups they're a member of. You can modify them by adding or removing them from groups depending on what your documentation says. Take a look at this. If we leave these ranges alone, we can split this one again. By borrowing another bit, we are changing the mask. By doing the equation, we can fulfill the requirement. Take a note, the subnet mask works. These networks are able to be divided this way. We now have ranges .192 to .223 and .224 to .225. 2 things to keep in mind. VLSM allows network admins to split their networks as they see fit. Just keep in mind that you need to start with the biggest network first. Also, connections between networks need to have their own networks. Take a look at this. We have 4 different buildings. Sure, we have 4 networks subnetted. However, what about the links in between these networks? Well, you'll have to make networks for them. Keep in mind that this is still your network, so we're not connected to the internet just yet. You can use the biggest prefix, /30, to allow 2 host addresses at the maximum. That is the smallest you can make a subnet. It is also normally used for these kinds of networks. When I mention these kinds of networks, keep in mind that it is simply the link between 2 routers. This is usually how networks are split up. When making your network, you need to ensure that every address is completely unique. You also need to be very realistic with the way you plan out address ranges, as end users will connect all sorts of things to the network. One more thing to keep in mind is that you have servers, printers, your default gateway, and other devices that need to have a static IP address. This ensures that that device will always use the same address and will be memorable. Address planning needs to be optimized, efficient, and well documented. That's it for this episode. In the next episode, we're going to learn about switched networks.